and thanks for joining us here in the SNIA track at SODACON. I would encourage you all to check out all the presentations in the track. We're going to kick it off this morning with discussions around the latest in storage management, then move on to computational storage, followed by a security topic, and then wrapping up the rest of the day with persistent memory. I'm Rochelle Olvers. I'm Rochelle Olvers. I'm a storage technology enablement architect with Intel, and I have a long history working with the industry standards associations. I currently sit on the board of directors for the Storage Networking Industry Association, and I've worked across many different aspects of storage. One of my other roles, if I can get this shared here, yes, is working as and leading the chair of the Scalable Storage Management Technical Work Group within SNIA that produces the SNIA Swordfish specification. So we'll be talking about in this first session is basically what's all the way cool new stuff we've been working on in the last year and a half and have on our plate moving forward here for the next little bit. And that basically boils down to looking at capabilities and partnerships around NVMe, NVMe over fabrics, and storage fabric management. While you do have a Q&A in this session, please feel free to use that. We have a dedicated Q&A session called Your Questions Answered on Storage Management that will be after these first two storage presentations. So if you have additional questions or want to see your questions answered, we will focus in that Q&A session on specifically on the topics that have come up from this session and Phil's session next. All right, so what we'll be covering now is really looking at, very broadly, providing some background on the redfish and swordfish RESTful hierarchies, map these, and talk about some of the common applications people are doing, specifically about those NVMe and NVMe OF integration work, and detailing a lot of that most recent functionality. We'll also spend a little bit of time and talk about how we are expanding and the work we're doing to expand to cover storage fabric management. So let's start at the basics. What are redfish and swordfish? This was a swordfish talk. Why do I keep saying redfish? That's an excellent question. So let me just start at the top here. DMTF redfish is a REST-based specification, JSON payloads. There's 3 different kinds of schema that we've developed for folks to actually be able to work with, but its focus is covering server, data center, and now fabric management. DMTF and SNIA have a long history of partnering together. So from when we needed to look at updating our management specifications and standards, we naturally just partnered with DMTF. So SNIA Swordfish is not different from redfish. It is simply the specifications, a storage management specification that extends the redfish spec. We leverage all of the protocol work. We leverage all of their underlying objects and schema. We actually even have some shared schema, and we focus as the storage experts on storage management and storage fabric management use cases. So these cover things that you'd expect to see: block, file, and object storage. And then it also, because of the new the REST-based and the scale, the architecture of redfish and swordfish, we're able to extend our traditional storage domain coverage to include converged environments. And we actually bring, between the partnership with redfish and swordfish, bring server, storage, and fabric management all together in a single cohesive ecosystem. Another thing that swordfish brings in and provides is the option for implementing class of service, intent or service level based provisioning, management, and monitoring, in addition to traditional management capabilities and structure. One of the neat things about the class of service piece is that you can add as little or as much class of service in conjunction with existing traditional implementation, or you can go completely to advertising only class of service-based interfaces. So what have we been working on lately? Well, this is where our alliance partnerships come into play. I've already mentioned, we have a strong alliance with DMTF and have leveraged a bulk of that work. In fact, we got our first spec out in only 9 months because we just leveraged the DMTF spec underneath that. But our focus for the last year and a half or so, plus some work we have at least through the end of this year, if not longer, has really been focused in a couple of areas. One of which is through an alliance partnership with the NVM Express organization. Redfish and Swordfish both have added a tremendous amount of NVMe and NVMe OF manageability capability. We also have started up a relatively new alliance partnership in this work area. We've had one there for a while, but in this work area to add expanded support in Redfish and Swordfish. So it's a 3-way alliance agreement for fabrics and storage fabric management. So I'll show details of that as we go here. All right. So let's talk a little bit about how Redfish is structured. There are a couple of different main things that we'll start with just from the real basics here. We start at the service root. So Redfish uses a model of fixed URIs. So you can see here for initial systems management, there's a logical split here between the logical view, the physical view, and the management view. And you'll see that logical physical management split pervasive. The other piece you have hanging off of the service root are a whole set of required services. These include things like account management, session management, events, tasks, sessions, and certificate management. You'll also find off the service root that same triplet hierarchy, logical, physical, and management, replicated for different types of technology. So this slide talks and shows kind of the base hierarchy for Redfish for systems or servers. So you can see here in this upper box, the /systems, so it's redfish/v1/systems. Under this entire hierarchy is where we do the logical view representation of all of the systems. The other notation here is that we have terminology, we say collections. This is, a group, it's an array, pick your favorite flavor of, just here's the pointer to, all of the sub-elements. And then we have the singleton resources that follow the, systems/ID URI. Underneath that, of course, obviously a system can't be reflected in just a flat structure very easily. So there's a bunch of subordinate resource collections or subordinate objects. Same kinds of things you'd expect to see: processors, network interfaces or Ethernet interfaces. There's also a storage collection in here, which I'll talk a lot more about when we get to the storage pieces. So again, that's all the logical representation. The physical representation is all done in Redfish/v1/chassis. So again, you see that same hierarchy of the collection with the singleton. And then you see these dotted lines here. What these actually are reflecting is what we call links. So obviously this is not fully populated because there'd be little lines all over the place. But the idea being here is that this logical instance systems, this instance of the system is associated with this instance of a chassis. And so there's a lot of both hierarchical and containment relationships reflected, as well as showing links or additional relationships between the different objects. Under chassis, you see things that, as largely as I think you would expect to see them, you see, power, under each chassis, you'll see information like power and thermal. The other thing you'll see is, and this is where there's a little bit of a blurring between logical and physical, but you'll see a few other types of resources that are built and dropped in subordinate to chassis. This one really just shows drives, and we'll talk more about that usage. But as you can see here, we contain them, the drives, in a chassis, which is a really logical relationship when you think about it. This reflects that a lot of the physical. It also has logical in that schema, but they're just contained here from a physical perspective, but the management of them is done in storage. The third major piece here is /managers. We won't really dig into this too much today, other than just to kind of highlight that three partnerships area there. In the managers collection and instances, this is a server. This largely reflects the embedded management, or BMC, for the system. The managers collection and instances could be logical management as opposed to physical management. But in the case of a server, this basically is, here's the logical view, here's the physical view, and here's the representation of the manager, which is the BMC. Okay, so that's kind of a few basics around how the hierarchy of Redfish, and as well as quite a few of the components, are structured. So let's go on and look at an application to the storage space. When we add Swordfish to the Redfish hierarchy, you still see that pairing over here of logical versus physical, but now you actually see this in /Redfish/B1/storage. So from a client perspective, you can come to this collection and find every instance of a storage resource, whether it's storage that's attached to a server, like we saw in the last slide, or whether it's just completely instrumented as an independent component and reflected here in the hierarchy. We still have all of those shared Redfish services. But then if we look under storage, what you see is exactly the objects you would expect to see. You see a relationship to your chassis. Obviously, it's like here, where is this thing? Where does this thing physically live? And what are its physical components? And then you get the volumes, the controllers, and storage pools as kind of three of the primary objects and points to think about. So all of these schema, the controller, volume, and storage pool, all attached directly to storage. And then there's links and relationships all over the place that, again, are not drawn out because you would not be able to see for all of the lines on screen. So one of the things to note here is that there is a volume collection here attached off of storage. There's actually two different usage models for dealing with volumes. The primary one in a Swordfish implementation is create a storage pool, and then from that storage pool, you create the volumes, or the allocated volumes here. And then this upper level volume collection reflects everything across every storage pool. So you have kind of two different ways to access and sort through where the volumes are. But the actual volume is instantiated over here inside the storage pool in the allocated volumes collection. All right, and again, we showed previously those drives mapping up to storage, but in a Swordfish configuration, your physical media is mapped and controlled by your storage pool. So you see that relationship here. The one additional piece we have in this permutation also is we've added a note into a registries collection, which I didn't talk about. I talked about services, but there's a series of registries that are like message registries, privilege registries, and we have added a new kind of registry called a feature registry. And this contains where an implementation will publish the list of supported features, and the features correspond to coarse-grained activities, discovery, provisioning, replication, high-level capabilities that the clients can come query and say, do you support this? And looking at the version here, so my example of V110 here will tell them exactly what properties are required. and exactly what functionality they can expect to see supported based on what functionality is populated in that list of advertised features. Okay, so that's a little bit of the basics of Swordfish, right? We have the basic structure, we have some of their primary components. There's others as well. We'll get to that in a little bit. But you still see that logical versus physical view, and now you've also got the addition of this registry that lets you see exactly what functionality the system supports. All right, moving to what's new. What have we been working on? We have been working for about a year and a half. This is about the beginning of 2020 on adding NVMe and NVMe OF full support to redfish and swordfish. There's been a little bit of support, but nothing that really took a good look at said, more than just a couple properties or so, but so nothing that really kind of came in and said, this is a comprehensive model and way to manage NVMe devices, and here's how you do it. And so that's really a lot of what we tackled here. Everything from Swordfish version 1.2.x on will include the NVMe work. Our latest version that just came out about a week or two ago, 1.2.2a, includes a bunch of the latest set of functionality. So there's a lot of content here. We have developed those management models that they reflect a unified view of all of the behavior for across all NVMe device types. So there's a universal model. There is not a different model from the NVMe perspective for different types of NVMe devices. We also provide a mapping document. The Swordfish NVMe model overview and mapping guide is the long name of the document. But the mapping guide then takes those models, propagates them down, and provides the mapping between the NVMe specifications and the redfish and swordfish specifications. So you can see exactly what properties, as we recommend or require implementation of, map to what capabilities in the underlying NVMe specs and interfaces. Another thing we've got provided is on our swordfishmockups.com site. We have a set of counting seven different mockups that are focused around these different NVMe configurations. So these first two are drives, and then we have a JBOF, and we're working on some new ones as well. And then we have a fabric attach array. We have an opaque array. The difference between those is, think of an opaque array as this. It's an array that presents itself as with its front end as NVMe, and everything else is hidden behind that. So we may see that it's not NVMe end to end necessarily, although it could be, but it's really how do we take today's arrays and put an NVMe front end on them, and what does that look like? And that's really kind of what we're looking at from what we call the opaque array. On the NVMe OF side, we have three different things here, one of which is very simply, the last one here is the NVMe OF Ethernet attached drive. So this is basically, what does a model look like? What does an Ethernet attached drive look like? And then, of course, we have the fabric attached subsystem, full NVMe OF configuration that also includes a lot of advanced concepts. We'll talk a little bit more about those in a minute. The other piece we've developed, and these first set are available in the 1.2.2, 1.2.1, 1.2.2 work, is the NVMe drives and Ethernet attached drives. So those profiles, again, are recommendations from the organization for what are the specific properties, attributes, behaviors that need to be instrumented for those types of devices. And those profiles then are used by the Swordfish Conformance Test Program, which we not only have for traditional storage as we've been developing, but we now have that CTP testing available for NVMe drives. So again, the NVMe drives and Ethernet attached drives, both variants. The other thing we're doing is clearly we will continue to expand this functionality over time. We have new releases that will be tracking new NVM Express features. One example of that is some work we're doing with a new proposal in the NVMe space called 6011, which focuses on really expanding the NVMe OF environment. There's also work around expanding our initial definition of NVMe domains and what those mean and how those get modeled. All right, so we've talked about NVMe stuff. Let's just take it back to that same mapping before and a little bit of an overview of what we've done here. So if we actually start with the box on the right over here, what we sat back and we actually did a really large mapping exercise at first, and then we kind of came in and said, okay, do these things roughly correlate and correspond to our existing model, or do we have to build a new model, or is it somewhere in the middle of that? And one of the maybe not so surprising things, but one of the things we were singularly pleased with was that we could actually map all of the concepts relatively straightforwardly to existing objects. So in our previous view of the storage hierarchy, we saw storage, we saw volume, storage pools, controllers. What we've done with NVMe is for the NVMe front end portion of the system, regardless of the drive, think of, if it's a drive, which I think is what I've reflected here on this one, this is the entire model, but for an opaque array, it may have additional functionality to it. That's that universal model I was talking about. This basically, the NVM subsystem maps to the storage hierarchy, and for some of the other capabilities, we had controllers. There's a whole set of things called NVMe controllers. They tend to be more pervasive and more transient than you would think of in a traditional storage environment, but the logical construct and the relationships all matched. So we've extended this schema here to cover those three different types of NVMe controllers. IO controller, admin controller, discovery controller. You'll have different instances of those, but they're in the same location under that /controllers. As you're likely aware, if you have any familiarity with NVMe, a volume is called a namespace. So we just reuse the volumes and add appropriate properties to come up with a namespace is represented using a volume object. And for representing all of the things that are kind of outside the scope of the logical hierarchy, we have mapped chassis and drive and physical information down again into chassis or chassis of different types, or the drive object itself. So for this specific example, which is an NVMe drive, you have a drive instance down here that reflects that up. One thing I haven't talked yet about is these storage pools right in here in the middle. There are a couple of different grouping mechanisms within more advanced NVMe implementations that also map exceptionally well to the storage pool models. We already have the hierarchy built in that says this is a collection from which volumes will be created. And that's really the same thing that these endurance groups and NVM sets have. And you may have a hierarchy that's an endurance group with sets created out of it, and the volumes or namespaces come out of that hierarchy. Okay, so there's quite a bit of the overview of the model, as well as kind of an example using an NVMe drive. I said earlier that there's more to the hierarchy and in the service route than the limited set we're showing here. And here's a good example. When we look at managing extended connectivity, other than what you saw on that first slide, which I'm a server, I have direct attached storage, we moved to creating what we call the Redfish Fabrics model. That's why it's kind of pinkish here, is that's Redfish. And from a Swordfish perspective, we simply leverage this. We have actually been working with them on expanding the definitions of things to make sure that all of the storage use cases are appropriately covered, but these stay in the Redfish space. And this is where we put in our connectivity and access management. So this particular diagram actually shows extended connectivity. So you can see in a fabric, you have switches, endpoints, and zones. And this zone, if you're familiar with technology for, using zone for, for some specific technology, this is a little bit more generic. This actually is intended to be that same kind of concept applied across. So it may not line up, one-to-one with, if you're expecting this to be just like fiber channel zones. It's, from a modeling perspective, it is conceptually there, but remember that zones behave differently across different technologies. When we move on a little bit and we talk about adding, access management, even in a more complex configuration, we leverage another part of the fabric model, which is, now says connections in here instead of switches. And so that is where you will actually see and manage the access right configuration. And then again, you see the endpoints and zones. So if you have combined connectivity and access management, you could potentially have switches, connections, endpoints, and zones, where the endpoints are common, have a common usage across the other two configurations. All right. We talked quite a bit of the overview of what's been going on in the NVMe space. So what else is going on? One of the major things we've been looking at is partnering with the Open Fabrics Alliance, and in particular the Open Fabrics Management Framework Work Group. I have to say that really slowly or it turns into a tongue twister for me. But the OFMF work group is working on building an Open Fabrics framework. So what we are doing in this space is the OFA is developing a lot of these Open Fabric frameworks and the concepts there. And then we are working with them as part of this three-way alliance agreement. Here you see Redfish, Swordfish, and OFA on the side, and working on mapping that to Redfish and Swordfish. So that basically kind of pops right in up here. And in our next presentation from Phil Caton, Phil will be talking a lot more about the details of what functionality we're covering here. But I will just largely just leave it as you can see, we've kind of got the base model for NVMe. There's a base model for fabrics, but we have to do some work across the organizations to flush those out for all different kinds of different networking technologies and every fabric technology variant. And that is a lot of the work that this Open Management Framework partnership is doing with this mapping. They are also developing, a framework for, managing fabrics. But from the Redfish and Swordfish side, what we're really looking at here is ensuring that our models are completely fleshed out for all of these different kinds of technologies. So just a little bit more about Redfish and Swordfish and our ecosystems. We have a very large and broad open source tools ecosystem. The way we're developing the standard is a little bit different than in years past. We tend to roll 3 or 4 releases a year, and almost all of the tools we use are in the open source space. So you can see things here. We have a Swordfish PowerShell provider framework. This has been built and developed by a couple of the folks in our group that work in PowerShell. So they've actually built a mapping and an integration into PowerShell and are working on extending that to some additional Microsoft integration environments. But that can run on both Windows or Linux. So if that's an environment you're familiar with, you can use that. Another one that we highlight quite a bit is the Swordfish emulator. This, again, just like with Redfish and Swordfish itself, actually builds on the Redfish interface emulator you can see over here. But the Swordfish emulator is flushed out to include all of the storage objects, And we're also adding work in, and it's showing up over here because we need some of the capabilities in this particular branch, but we're also adding support for fabrics and a lot of other capabilities there for that joint work with the OFA, redfish and swordfish organizations. There's a couple of other things that we've had built just as good examples for how clients might want to use and interact with Swordfish, such as the PowerShell toolkit and the Datadog sample dashboard integration. The Power BI sample integration and the Datadog sample, not the PowerShell toolkit. But these two are specifically developed, from an enterprise or data center management perspective to say, how would I use Swordfish, and to provide some very specific examples as well as, a preliminary integration for that. On the redfish side, you can see a lot more of the base capabilities, where the Swordfish ones have focused on higher level usage and applications. The redfish provides a lot of the base tools that we just leverage. Everything from validating the service through the interop validator, the service validator, the service conformance check, to the ability to help create mockups and a server to run mockups and have it respond as a live system, although a static one. So there's a lot of variance in the tools available here. All right, so, where to find more info about all of these things and how to get engaged. We've talked about 3 different organizations here, so I've provided you links and references for 3 different organizations. With the Swordfish, all of our specs, standards, mockups, users guides, etc., are all available at SNIA.org/swordfish. So you can go there at any point, and should be able to find links to everything else we're talking about here. The Swordfish Specification Forum, if you are not a SNIA member and you have questions about Swordfish, you can go to swordfishforum.com. This is the same site as redfishforum.com, so you can get questions answered about either redfish or Swordfish specific questions. If you are part of the SNIA organization and would like to engage, the work all happens and the magic all happens inside the Scalable Storage Management twig. So you can go to SNIA.org and find the information about either joining SNIA if you're not a member, or if you are a member and want to start engaging with the SSM twig, go to members.snia.org and request to join the group. The other piece we have that's very important is the Storage Management Initiative. This, again, focuses on marketing and education development and helping to promote the standards. And we promote basically storage management standards across the board. It is not exclusive to Swordfish. We actually work on promoting redfish, promoting Swordfish, promoting NVMe Express, and saying these are how everything works together. On the redfish side, you can go to dmtf.org/standards.redfish. You can start at redfish.dmtf.org. There's a couple of different ways to get there and a couple of different pages, but largely that's where you'll find all things redfish. In the Open Fabrics Alliance, as the tongue twister I mentioned earlier, the Open Fabrics Management Framework Working Group, the OFMF, you can join any of these groups. The Open Fabrics Alliance is an open organization, and so you can attend meetings or join and participate, and all of the work is done in the open source space. If you're interested in that collaboration work, please contact me, and I'm happy to give you more information on that. Thank you very much for your time. Again, if there are more specific questions, please put them in the Q&A, or feel free to join us again at the Q&A session after the next session, which will be Phil Caton.